DeepSeek dropped a major bombshell today, a multimodal model called Janus-Pro 7B. With 7 billion parameters, this thing can not only see images but also draw them. It's even outperforming DALL-E 3 and Stable Diffusion on several benchmarks. We gotta dive deeper into this.
Compared to the previous Janus multimodal model, Janus-Pro comes with 3 major enhancements: more effective training strategies, a broader set of datasets, and larger model sizes. These improvements significantly boost its multimodal understanding and text-to-image instruction-following tasks. Take a look at Figure 1 here. It shows how Janus-Pro stacks up against other models on various benchmarks. Notice how it excels at multimodal understanding tasks such as POPE and MME perception. Janus-Pro consistently outperforms earlier unified and even task-specific models, and its advantage becomes more pronounced at larger scales. Then, in Figure 2, you can see its text-to-image generation accuracy on benchmarks like GenEvil and DPG Bench. Interestingly, it scores higher than specialized systems like SD3 Medium and DALL-E 3. In a nutshell, this model is all about unifying multimodal understanding with generation and doing it more effectively than before. It's a significant leap forward for complex tasks that demand both general and specialized capabilities. Throughout the rest of this transcript, we'll explore the methods, experiments, and results that bring these achievements to life. Now let's talk about how Janus-Pro improves on text-to-image generation compared to the original Janus. If you look at the examples here, you'll see a side-by-side comparison where Janus-Pro 7B's outputs are much more stable and detailed, especially for shorter prompts. One example is a simple Blackboard scene with the word hello. Janus-Pro writes it clearly, while the earlier model struggles with clarity. Another example is a sunflower image. Janus-Pro captures the finer textures of the petals and even subtle sunlight effects. Why is this improvement so big? A lot of it comes down to the challenge of using a single visual encoder for both understanding and generation. These tasks can have conflicting representation needs, which Janus handled by decoupling the visual encoding process. Janus-Pro scales that approach further by refining training, expanding datasets, and growing the model size to 1B and 7B parameters. As a result, you'll see a jump to a 79.2 score on multimodal understanding tasks, surpassing models like TokenFlow and Metamorph, plus top-ranking performance on the GenEvil leaderboard for instruction-following tasks, outdoing DALL-E 3 and Stable Diffusion 3 Medium. Bottom line, Janus-Pro makes a big leap in visual generation quality by building on Janus's architecture and pushing it even further. Let's dive into Janus-Pro's architecture, which neatly separates the processes needed for multimodal understanding versus image generation. For understanding tasks, a special encoder creates high-dimensional semantic features from the image. These features are then flattened and mapped into the language model's input space with an adapter. For generation tasks, the approach starts by tokenizing images into discrete IDs. Those tokens are transformed by a generation adapter and fed into the same language model. Here's the key. Both of these feature sequences, one for understanding, one for generation, get combined into a single multimodal sequence. An autoregressive transformer processes the sequence to predict language or image outputs as needed. There's also an extra prediction head that helps with visual generation to keep the model versatile and precise. The training happens in 3 stages. Stage 1 focuses on training adapters and an image head. Stage 2 does a lot of the pre-training, updating most parts of the model except for the core encoders. Finally, Stage 3 is fine-tuning, which unlocks the encoders for additional refinement. It's an iterative approach that systematically brings the entire model together. By separating encoders while still using a unified transformer, Janus-Pro finds a nice balance between specialization and integration, leading to its strong results on multimodal tasks. Next, let's discuss optimizations and scaling strategies. 2 key tweaks address inefficiencies spotted in the previous training approach. First, the team extended Stage 1 training on ImageNet, which helped the model do better with pixel-level details. Although the language model part was kept frozen, this extra focus led to improvements in generating clearer images later on. Second, during Stage 2, they emphasized standard text-to-image datasets over ImageNet, boosting the model's ability to handle more detailed textual prompts and making the whole process more efficient. Stage 3 also got a tweak. The ratio of text-to-image data in fine-tuning was lowered slightly. That kept the model strong for visual generation while enhancing its performance in multimodal understanding tasks. Data scaling was another big factor. For understanding tasks, they expanded the dataset to about 90 million samples, covering everything from image captioning to document parsing. On the generation side, they incorporated 72 million synthetic aesthetic samples to balance out the noisier real-world data in a 1-to-1 ratio. This combination made outputs more stable and visually appealing. Finally, they explored bigger model sizes, going from 1.5B to 7B parameters. That larger model converged faster and showed marked improvements across the board, demonstrating that Janus-Pro scales nicely. Now let's zoom in on the architecture and training specifics. If you look at the differences between the 1B and 7B versions, you'll see changes in embedding size, the number of attention heads, and the number of layers. These differences let the 7B version handle more complicated tasks and provide more depth, but it still uses the same context window of 4096 tokens and the same vocabulary size. In terms of training, remember the 3 stages we talked about? The learning rates go down gradually from stage to stage, and most of the training steps happen in stage 2, since it's where the bulk of the unified pre-training occurs. The data ratio also shifts across stages, balancing how much the model sees of multimodal, text-only, and visual generation data. Under the hood, they used DeepSeek LLM as the base language model, which can handle 4096 token sequences. For vision encoding, SIGLIP is employed to capture features for understanding tasks, while a separate codebook-based encoder is used for image generation. Adapters connecting these encoders to the main model are small, just 2-layer networks. Input images were standardized to 384 by 384 pixels, with padding or cropping as needed. Training ran on a powerful cluster of NVIDIA A100 GPUs, up to 32 nodes in total. Thanks to efficient PyTorch pipelines, the smaller model was ready in about 7 days, and the larger model took about 14 days. After that, they tested them on well-known tasks like GQA, general question answering, to verify performance. Check out Table 3 here to see how Janus-Pro holds up against other leading multimodal models. It performs strongly across many benchmarks, shining in both understanding-focused tasks and unified tasks. Notice how Janus-Pro 7B generally tops other models, including some that are bigger, though there's a slight drop in performance on GQA. This reaffirms the idea that decoupling visual encoding for understanding and generation can reduce conflicts and enhance overall performance. For visual generation, 2 benchmarks are highlighted: GenEvil and DPG Bench. GenEvil tests the model's ability to generate detailed, compositionally accurate images, while DPG Bench challenges it with complex, dense prompts that require close semantic alignment. Janus-Pro manages to score well on both, suggesting it can handle both simpler compositional tasks and more intricate semantic requests. Its success in both multimodal understanding and visual generation underscores a nice balance between efficiency and capability. It also shows that scaling and refining architecture can lead to top-tier results without always needing to go to extremely large model sizes. Let's now turn our attention to Janus-Pro's text-to-image generation performance in more detail. On GenEvil, which tests how well a model can follow instructions for image creation and evaluate the resulting outputs, Janus-Pro 7B reaches about 80% accuracy. This score outdoes other popular models like Transfusion and DALL-E 3. It follows instructions more precisely and delivers highly accurate results, whether it's about identifying objects or matching colors. Then we have DPG Bench, which really pushes models with dense, complicated prompts. Janus-Pro 7B scores an impressive 84.19 there, beating SD3 Medium and DALL-E 3. It consistently produces images that are coherent and aligned with the context, even when the prompts get lengthy or tricky. If you take a moment to check the sample outputs, you'll notice the images are quite realistic and detailed, even at a modest resolution of 384 by 384. From everyday objects to imaginative scenarios, Janus-Pro keeps the visuals semantically on point and contextually meaningful. This range of abilities further cements its position as a strong choice for both unified and generation-specific tasks. Want to see some real-world examples of what Janus-Pro 7B can do? Let's walk through a few of them. First, imagine a coastal landscape. Janus-Pro can describe fine details like sedimentary rock layers, sandy shores, and even mention an overcast sky, painting a picture that feels dynamic. It also identifies landmarks in a culturally and geographically accurate way, such as specific Chinese sites or features. One fun example is a cake designed around the Tom and Jerry cartoon. Janus-Pro picks up on the cheese-themed decorations and a small fondant house. It also does a good job at text recognition, capturing phrases like "serving Seoul since 2012" without mixing up letters or words. On the generation side, you might see creative prompts, like a glowing crystal ball or an astronaut in a dense jungle. In each case, the model produces images that are not only vivid, but also coherent with the prompts. Even whimsical scenes like a whale among glowing lanterns are depicted with good semantic alignment. These examples highlight Janus-Pro 7B's ability to handle both the analytical and imaginative sides of multimodal tasks. Before we wrap up, let's summarize the main takeaways. Janus-Pro brings key improvements in training strategies, data curation, and model scaling. Thanks to these upgrades, it's able to push the limits of multimodal understanding and text-to-image instruction following. That said, there are still a few constraints, as the input resolution of 384 by 384, which can affect tasks needing very fine detail, such as optical character recognition, OCR. Another is that reconstructing images from the vision tokenizer can make small details, like intricate facial features, less clear. The researchers suggest that raising the input resolution could help tackle these challenges, improving both the understanding and generation aspects for fine-grained tasks. So while Janus-Pro is already moving things forward in exciting ways, there's room for even more progress by addressing resolution-related limits. That brings our discussion to a close. Thanks for following along.